Hello Internet, so today we've got a very nice laptop to fix. It's an ACER A15, I think it's 58 model with i7 11th gen and RTX 3060 GPU. Originally came to me with no power, but it turns out it's actually powering on, but it's, after pressing the power button, it's switching itself off very briefly. So let's just switch to the board view and then try to figure out what's wrong with it, and maybe we can fix it. We already disassembled the laptop. We've got a board in front of us. It's a nice Compal LA-19lP motherboard from 2021. I think the laptop is about 3 years old. And I've done some basic measurements. I know the main 19 volts power line is fine. It's actually starting and it's flowing through the motherboards everywhere. It's powering the 3.3 volt LDO power line that in terms powers on this chip, keyboard microcontroller, and that keyboard microcontroller is starting the whole board. So after that we should have other voltages, main 3.3 volt line, 1.8 volt line, and so on and so on. So we don't have that one. The laptop is powering on briefly and then switching itself off. So first thing what we have to do is check the resistance on those lines, because I've worked on those boards before. I know there's a common fault with these ones that PCH is actually dying for some reason. Well, we're going to talk about why is that in a moment. But let's just do the basic measurement and see if there's any shorts on the board. Right, in order to check the PCH chip for this particular model, which is HM5700, there's you've got those little capacitors at the top of the PCH, and then they correspond to the power line directly inside the PCH. So there's four main lines that we have to check. There's 1.5, which is this one, the capacitor here, and then on a good chip we expect resistance something above 50 ohms, something between 50 and 100 ohms. This little one on this side is 1.8 primary, so we're expecting a resistance over 1 kilo ohm. Another one just below is the 3.3 volt line, so this one should be high, should be in kilo ohms. And there's this little tiny one on this side. The power line is called 1.8 auxiliary primary PCH, and on that one the proper resistance is about 400 ohms, 500 ohms. Anything over 350 is actually okay. So we just measure those capacitors on our board, and then we go from there. Right, so if I zoom in to PCH chip, I'll try a bit further out so you can actually see the multimeter. And then we're going to measure the resistance to ground on those fours line. So the first one is 1.05 primary PCH. So we can measure the resistance to ground on this capacitor here. As you can see, it's short to ground, 0 ohms. Now 1.8 volts on that one here. And we got 0 ohms to ground, so that's full short. And we got 3.3 volts power line. And short to ground again. So I can say with certainty, without doing any short circuit test, that this PC chip is bad and needs replacing. We can also check the resistance on 1.8 auxiliary PCH line. This one surprisingly is resistance is quite high, so for 1 kilo ohm. But it doesn't matter in this case. The PCH is definitely bad and needs to be replaced. Right, now let's talk about why is that, why those boards fails, why the PCH chips dies, it cooks itself. Well, this is a gaming board, so you'll produce a lot of heat. You've got a nice CPU, GPU that heats up a lot. The board itself is quite bad actually. The heat distribution is really bad. The thickness of board is slim. And the worst of all is this SSD slot. You see what the ACER engineers did? That's the main slot for SSD. It's just directly above the PCH chip. So not only PCH chips getting hot when you're actually using the laptop when gaming. The normal temperature for when you're gaming PCH should heat up to about 50-60 degrees. But with the heat distribution on this board is quite bad. Plus there's SSD. The new SSD, they heat up quite a lot as well. There's tiny little thermal pad at the top of that chip, but it doesn't really help a lot. So all that heat going back to the PCH. The PCH is just getting too much heat and it's cooking itself basically. That's what I think it is. So if you got this laptop, if you got this motherboard, there's a lot advice for you. Do not use this SSD one slot, use the other one. There's another one on the other side of the board. Use that one. That will take away some heat from PCH and hopefully it will prolong its life. I really done a lot of those replacements on those boards. I know this is the main culprit of this board, so don't use this piece. Don't. The funny thing is that the ACER is putting that SSD. The funny thing is that the ACER is putting that SSD in this slot by design. So when you buy the laptop from the factory, it will be used in this slot, which is just asking for problem if you ask me, but it's just what it is. It is what it is. It will probably survive 2 years till the end of warranty, and after that it will die. It's good for them, not so good for you. Right, so now that we know the PCH is bad, that we need to replace it. Well, replacing the whole chip is just not very difficult if you know what you're doing and you've got the BGA equipment. There's some things that you have to be careful of. We're going to talk about that, but how do we get the chip? Well, I can't really ask Intel to send me this chip, so I got two options. Either I buy it from China, that is advertised as new, but it's never new, so it's like a big hit and miss. You get a good chip or you get a bad chip. There's no way to actually check it. Or, in this case, I'm quite lucky because I've got exactly the same motherboard with different faults. This one's got well, basically there's a big scratch on GPU, so I think GPU might be dead, and basically the main thing is the one of the CPU face is shorted and the CPU is bad. So that board is definitely for donor board. But I've checked the PCH power line and they all look good, so I'm hoping the PCH is going to be good on that one. We're going to check that one to see if they actually got resistance to ground and good measurements. So again, we take the multimeter. Let me just zoom out a little bit. Right. So once again, 1.05 primary PCH. So we're expecting about something between 50 to 100 ohms on that one. It's this capacitors here. And we got 97 ohms, which is quite good. Now 1.8 primary. This is this capacitor here. Oh, we've got 1.4 kilo ohms, which is perfect. Now 3.3 main line, which is the capacitor. We've got 7 kilo ohms, which is very good. And then lastly, there's this little capacitors here, which is VCC PCH auxiliary line 1.8 volts, and on that one we're expecting to have about 400 ohms. We got 415 ohms, so which is quite good. So the measurements showing that the PCH possibly is alive, is quite possible that it's alive. So what we're going to do, we're going to get this PCH, reball it, and we'll try to install it in this board and see if it works. So let's get into it. I bought myself something nice. This is this magnetic stencil. This is apparently the next big thing. Everyone is using that to the reballs. And I've done a couple of Ryzen CPU. It's actually quite good. It's very accurate. It's much better than the old-fashioned old 190 by 90 stencils. So we got SRKMA, which is HM570. So we've got the stencil, we've got the magnetic stuff for it. So let's first try to get the chip out of the board, reball it, then install it in new board and see if it works. It looks good. Everything seems to be fine. All the bolts are in place. We'll leave it for a little bit to cool it down. We'll see the resistance on the main power lines. In the meantime, we're going to prepare the other board. This is how it looks. Just another look. If someone's wondering, the bolt size is 0.35. I usually use 0.30, but this stencil was for 0.35, so that's what we used. It could still should be alright. I've done 35 before, it was fine. Yeah, so that's good. So we're going to leave it for now, and we're going to prepare the other board. Okay, we're gonna chip out. We'll clean everything a little bit. Let's see the parts now, how they're looking. Everything seems to be fine. Yep. Yep. Yep, they're all fine. Now, remember we had short on 1.8 and 3.3 volts. Let's check resistance now without the actual chip on the board. Let me get a multimeter. Right, now we have to go to coils. This is because there's no chip on the board, but we know from board view and then schematics that, let me see if you can actually see the resistor. Right, this is 3.3 volt coil. Hold on, I want you to see it. Right, I think you see it now. Right, so this is 3.3 volt, so we're expecting kilo ohms, and we get kilo ohms, 7, and it's crazy. And 1.8 volt, I will show it to ground. Without the chip, it is also at kilo ohms. We'll check 1.8 auxiliary PCH as well. We got kilo ohms. Everything is fine, so the culprit was definitely the chip. So everything is ready for the new chip. Everything is clean. So we'll install the new chip now. Right, we replaced the PCH chip. Now we have to do the BIOS. Actually, what we have to do is just clean management engine inside the BIOS. But in order to do it, we have to read the BIOS first. So I've got the chip in program already. I'm going to detect it. That's the one. Select device, read ID, and we're going to read it. It'll take a few seconds, so just bear with me. Oh, we got it. Now we're going to save it. I'm going to put it on pulpit somewhere. Let's call it 1, 2, 3, and then save as. So we've got the BIOS. Next thing we have to do is use the program Management Engine Analyzer to see the actual version of Management Engine. So we open that program now. There's a little program called ME Analyzer or Management Engine Analyzer. And then This is our BIOS file. I'm going to open it. And then we've got some data that is interesting for us. Well, so the version is interesting. The version is that what we need to change actually. Clean. So that's important for us. The flash image tool that was used is actually important because we have to use the same flash image version, otherwise we'll have problems. And we've got system 5 initialized. So that means the PCH has been initialized, and then we have to clean it basically. So this needs to be configured. So in order to do that, we have to open another program called Flash Image Tool version 15. We got it here somewhere. That's the one. Alright, so we open that program. We're going to once again open our BIOS file inside it. Just drag it, drop it inside. Then we're going to change some settings. Generate immediate file. Go now. Go close. We're going to save as, and we're going to put 123 XML. Save. We do close for now. And now going back to Management Engine Analyzer, we need to find the respiratory version of that particular version of Management Engine and replace it with a clean one. So going to browse through another program called Respiratory Management. Where is it? I've got it somewhere here. That's the one. Version 15. So what is interesting, we have to find exactly the same number, exactly the same version. So it's 15.0.30.1716. So it's going to be here. No, 17. What was it again? 1716. So it's going to be that one. So that's the one. So we copy that file, put it on desktop, and now we're coming back to Flash Image Tool. We open Flash Image Tool, and we got another called 123, and then decomp. In decomp, we've got a file called me subpartition. So that one we have to replace. That's the bad one. Well, that's the one that's been initialized, and then we have to replace it with the clean one. So this is the file that we have to replace. So we're going to rename it to me subpartition bin. We're going to replace that one. Okay, I think I've misspelled something. Yeah, I've misspelled MS subpartition. And we open Flash Image Tool again, like that. And then we open that file, and then we press build image. Yes, and we've got clean management engine. We've got the actual BIOS that we can use for the PCH that we replaced. Ready to test it. I've connected the RAM memory, I've connected the screen, parallel radiator on CPU and GPU. So we're going to power it on. The first thing before we actually press the power button is to check the crystal clock for installation. So let's see if we got installation. We do. We got a nice frequency from one side, and a nice frequency from the other side. That means the crystal chip is working. PCH is oscillating, so we can try to start it up. We're going to simulate the power button and see if the board's actually working. If we can short this pin here, yeah, it's starting, taking 2.3, 2.4. Well, it should reset the ACERs. Yeah, turns itself off. It's resetting, yeah. 2.3. What we want is the current to go up and down, up and down. That means the CPU is actually executing the BIOS, and we should have another reset possibly. 2.4, 2.3 amps, 1.6. Oh, I think I saw the picture. Hold on. I think it's starting again. Yeah. And we have a picture. So it's a success. There you have it, that's another fix. If you enjoyed the video, please consider subscribing to my channel, liking it and commenting for the YouTube algorithm. Also, if you live in the UK and you've got a laptop to fix, please contact me directly in the email provided below for all kind of BGA repair and components level repair. I hope you learned something today, and then see you on the next one. Bye.